All right, so here's 7.4. As soon as it loads, anyway. It starts off just, do you know the formulas? If you have a difference of two angles, do you know what to do? If you have a sum for sine, there's basically two sets for each one. Sine has two sets for sum and difference. Cosine has a sum and a difference. Tangent has a sum and a difference. So I'm going to give you all those in a second. So here they're just going to test you. Do you know what they are and how to apply? Over here, the first question, we have a sum of two different angles. So you apply the formula, because right now you can't really do anything, because if you add them together, you get a weird angle. But if you apply the formula, then you can deal with pi over 4 and pi over 3 separately, which is, these are values that are on the circle. So it's a lot easier. Over here well, they're already separate, so who cares, right? Let's just look it up on the circle. Same thing here, it's the difference. So apply your formula, okay? So yeah, all we're really gonna do is apply the formula and look at the unit circle. It's gonna be pretty straightforward. I think this is one of the easier sections. Let's see here, anything weird in here I should get rid of. Guess that's fine, okay. So let's start. I think around here might be fine. Let me look at mine. I always look at the examples I chose last semester just to see if they're not ridiculous. Okay. So let's start with the formulas first. Let's write them down. These are new formulas I have not given to you. So 7.4, sum and difference formulas. All right, can you guys see that okay? I'm using a different color, it's a little lighter. Just let me know. I can switch to darker colors. Okay. All right, so we'll call the two angles alpha and beta. So right here, alpha plus beta. So that's going to equal cosine alpha times cosine beta. I guess we could put parentheses right here. You don't have to, but it helps. Minus sine alpha sine beta. So notice how if you have a plus in here, it's going to be minus. It's the opposite when you have cosine. Second one. So same deal, but with a minus, so just switch the middle term. So cosine alpha, cosine beta plus. Sine alpha, sine beta. Okay. Number 3. Now this is the sine alpha plus beta. That's going to be, let's see here. Sine alpha is sine alpha cosine beta plus cosine alpha sine beta. All right. Sorry. You're ready. Sorry, give me 1 minute. I'm sorry. My PDF got all blurry. I think it froze. 1 second. Sine. I don't have these memorized, so I don't force you to memorize them either. Okay. The minus. So see how this is a plus, and this is a plus. So minus sine alpha cosine beta cosine alpha sine beta. All right, so there's two sines, two cosines. Now tangent. Tangent is really just built from these here, because they're just, remember, tangent is defined as sine over cosine, right? So you technically could derive it from this, but I'm just going to go ahead and give them to you. You get alpha plus beta. That'll give you tangent alpha plus tangent beta. One minus tangent alpha tangent beta. So all you have to do is switch the signs to get the other one. Okay. Okay. So write the exact same thing, just switch the signs. Minus, plus, minus, plus. Okay. All right. So there's all 6. I think I already gave you these, but just in case, I think it comes up later in this section. Cosine pi over 2 minus theta, because you go to sine, if you shift them, sine of pi over 2 minus theta becomes the cosine. So you can shift to become the other one if you do a horizontal shift like this. So that is all the formulas we're going to need for 7.4. Okay, no, wait a second. Okay. All right, so this is problem 4 from your homework. Pretty sure it's problem 4. So you can't use your calculator, you have to find the exact value. So that's the whole point of these formulas, just to avoid using or getting a approximate answer. You can get an exact one using this sum and difference. Okay. So that was the one from earlier. So this is your alpha right there. This is your beta right here. So just plug it into the formula. So use formula number 1 right up here. So just alpha, beta, alpha, beta. That's it. So cosine pi over 4, cosine pi over 3, and then it's minus, right? Yeah, minus sine pi over 4, sine pi over 3. So now we gotta look it up on the circle. All right, where the heck is the circle? Let's see. All right. So the first one says cosine of pi over 4. So that's going to be this x value right here. To put that in there for cosine pi over 4. So square root 2 over 2. And then it says times cosine pi over 3. Pi over 3 is right there. So times a half. So I'm just going to put them in parentheses. That way we know what came out. Okay. And then it says minus sine pi over 4. That's going to be the same. Square root 2 over 2 times sine of pi over 3, which is square root, whatever. Sorry, I messed that up. Okay. Square root 3 over 2. Let me switch back. Okay, so all these values came from your circle. So we're able to deal with these two angles in here. Look it up on the circle, and now we just multiply and add. That's it. So square root 2 times 1, 2 times 2, square root 2 times square root 3, 2 times 2. And that's it. We can combine these two fractions technically, but you can't do much, right? You could do this. That's it. All right. Any questions on the first example? Do you see how we apply the formula to alpha, beta? And all the alphas and betas are right there using formula 1. Okay, so let's do another one then. That one's cool. It's not too bad, right? So this is part A. Well, let me make some space here. This part B is super short. All right. Part B. The reason they do this is they want you to see the difference. You see how this is cosine pi over 4 plus cosine pi over 3. But over here we had, they were inside. pi over 4 plus pi over 3. Here, they're two separate functions. So they're not the same at all. This is actually easier because you can just look this up, right? On your circle, pi over 4, cosine pi over 4 is going to be square root 2 over 2. Cosine pi over 3, that'll be, we said earlier, 1/2. That's it. So we can combine it into 1 if you want, but that's about it, all you can do. Let me show you the answers. Right here. Notice how they factored the fraction. I have it underneath, which is fine. And then I have the 2 underneath, which is also fine. You can leave it in front either way. It doesn't matter. Like, I don't care how you write it. I'll take either one. The computer should take both. Okay. Number 5 is the same nonsense. They just have a weird pi thing right here. But this is on the circle. This you may have to reduce. Let's see here. Number 6. 11 pi 12s. This might be worth it. These. Do you have any questions on 5A? Does this look doable? This is almost the same, but this one's a little harder because of this guy. Do you know how to deal with that 31 pi thirds? Okay, do you see how that's probably bigger than a full circle, right? What is 31 pi? Let's see here. So real quick. Throw out some scratch paper. Yeah, we could do that. I mean, that would be easier. We could. Let's see here. So we know that 360 and 2 pi are the same thing, right? As far as distance on the circle or going around the circle. Assuming you all understand that part. 2 pi is technically 6.28 degree as a decimal, 6.28. 31 pi divided by 3. The hell is that? Notice that is way bigger than 6.28, right? And you guys see that, or is that too bright? So we know that it is more than a full circle. So this thing went around a couple of times, then landed somewhere. So we would have to subtract 2 pi. You could change the degrees and then subtract 360 if you want to. But doing this at least shows me that I'm for sure, I am very sure that this is now bigger than 1 full circle. Okay, so what you could do is subtract 2 pi over and over, because that's the same as 360, or you can convert this guy into degrees, which would be what? Three goes in a, that's 31 times. So this is actually 1860 degrees. That's pretty big, right? So it went around quite a few times. So what we would have to do is subtract multiples of 360 until we're below 360. Here you'd have to subtract multiples of 2 pi. But listen, I think this one makes more sense to most of y'all. So let's just use this guy. So 1860, we'd have to convert at the end though. I know this is for sure more than 360. How many? I don't know. So 360 times 5 is 1800. That was a good guess. So if we subtract 1800, that's technically 5 full circles, right? So that would be 60 degrees. So this is just 60 degrees. So this guy is actually just pi over 6, because on the circle, if you look at a unit circle, right, 60 degrees is the same as pi over 3, not 6. Okay, if we look at our circle, see how 60 is pi thirds? So we can just use that guy. So let's go back to our question. So we can rewrite the problem to something we should know how to do. So this right here will be the same as sine, right? 7 pi, see if I can write with this little pencil thing slowly. Then again, I can barely write with a real pencil, right? So who cares? Pi over 3, yeah. So use this one because 7 pi 6 is technically on your circle. If you open up your PDFs, I don't lose this. You'll see that this should be on there. This will be my my alpha. That's ugly alpha. They look like Jesus fish, but as good as it's gonna get. This is the beta right there. So just use your formula, and it'll be just like the last example. The only thing you had to deal with was this weirdo angle. So adjust this angle to this, and you'll be okay. Does that make sense? Is the next part, the next step clear? It'll be just like the last one. Right, I'm gonna write it down on paper. That way we might as well just do it real quick. I'll write the question down. Example 2, problem 5, part A. So we change sine of, I'll switch over in a second. 7 pi over 6 minus 31 pi over 3. We change that guy into sine of 7 pi 6 minus pi over 3. There we go. Now, pi over 3 is right here. 7 pi 6 is right there. Right? So this is my new alpha and beta. Okay. So we'll come back to this once we apply the formula. We'll be good. All right. So sine, write it one more time. That becomes, according to the formula, where is it? Here it is. Sine minus the difference formula. So sine alpha over 6 times difference cosine beta minus cosine alpha sine pi over 3. Yeah. There we go. So now we just look at the circle. 7 pi 6 for sine on your circle. The y value, right, is negative 1/2. Cosine of pi over 3. That's going to be 1/2. Positive. Minus, that's built in. Cosine of 7 pi 6. That'll be negative square root 3 over 2. Times sine of pi over 3, which is positive square root 3 over 2. Okay. So at that point, we apply the form, we adjust the angle in the scratch paper earlier, apply the formula, looked all this up on the circle. Now we just multiply numbers and deal with these signs. That's it. So negative times positive, that's a negative, right? Negative, negative, that'll be positive. Square root 3 times square root 3, that is a square root 9. 2 times 2 is a 4. So that becomes negative 1/4 plus 3/4, which is 2/4, which is 1/2, right? You guys agree with this? Anything that doesn't make sense or is strange? See how it's the same exact thing as the last example. We just had to adjust this angle. We have to find a coterminal angle that's easier. That's, on the circle, basically. Okay. So let's do, so on the homework, I think they kind of start off with a harder one. So let's do an easy one first. Check this out. Right here. They want you to know, well, eventually you have to figure this out yourself, right? They told you that you can break it up into these two, because these two are on the circle. But if I gave you this 11 pi 12s, like, would you have been able to just know this right away or figured it out? It's kind of hard, unless you're a master at fractions or something, or you can change it to degrees and that may become more obvious. So they basically said, okay, here's the angle, change it to the alpha and beta, right? So let's do an easy one where they don't tell you, and then we can look at this, I guess. Or there might be another one. Let me close this guy here. Okay. No, maybe not. Whatever. Well, let's do my example instead then. Example 3. Find the exact value of cosine 75 degrees. Okay. So this is where you need to think about this. 75 is not on the circle. But can you break this up into two angles that are on the circle? And there's more than one right answer. So how would you break 75 degrees? Think about it for a little bit. Yeah, 30 and 45 equals 75. So yeah, that's a good choice. Let's do that. So 30 degrees plus 45 degrees. So there's my new alpha and beta. So it's a little easier to see if you're in degrees. But if this was like a weird radian, I'm like, I don't know. So yeah, change it. Once you've separated them, apply your formula. So the next part is just literally plugging in numbers into a formula. So where is it? Number one, formula one. So cosine of 30 degrees plus 45 degrees is going to equal cosine 30 is the alpha, cosine 45 minus, not plus, minus sine 30 sine 45. Okay, so all I do is apply the first formula. Now we just look at the circle again. What is cosine 30? What is cosine 45? Now, if you don't have it memorized, open up your circle. Cosine 30. Cosine 45. You guys know how to use the circle. Let's see here. For cosine 30, yeah, that's going to be the x value. That's right, for 0, 3, or 2. And for 45, it's the x value right here. So that'll be square root 3 over 2 times square root 2 over 2 minus, now we do the y values, right? Sine 30. This is right here, right? Sine 45. And that's it. At this point, just multiply it out. Root 3 times root 2 So you can't add the same roots if they're not exactly the same, but if you're multiplying, you can always multiply the numbers inside. So square root 3 times square root 2 will simply be this. 2 times 2 will be 4. Just a quick reminder, right? Can you add these? And if they're not exactly the same, you cannot. So if you see something like this, just leave it alone. That's it. It's the best you can do. If you see something like this, though, that's 2 of them, right? That's the ugliest equals of ever written. Let me fix that. 1 plus 1 root 3 is 2 root 3. These are different. I can't add them. So these follow the rules of like terms. Multiplication, you're good though. 3 times 2, 6. 1 times that is itself. 2 times 2 is 4. Okay. So far, is this section making sense? I'm hoping it's not too bad. Okay. Let's do number 8. That one, they don't tell you anything. Check this out. This is what I was talking about. I was looking for one of these. They just give you the angle. You need to pick, you need to find the alpha and the beta. So can you, by looking at this, think of 2 fractions it'll break into? And if you can't, right, because it's hard, change it to degrees. I think that's the easiest path or strategy here. Well, let's do number 8 next. All right, you guys cool on this page, right? Okay. Example number 4. Example 4. Find the exact values. Part A. I'm going to rewrite the question just so it's a little easier. (13 pi) over 12. Okay, so let's go over here and reduce it. Or convert it, I mean. Multiplied by 180 over pi. Cancel the pi's. Does 12 go to 180? I don't know, maybe. 12 divided by 180 divided by 12. Yeah, that's cool. Okay, so this is really 13 times 15. Right, because the pi's cancel 12 into 180. I'm only left with 13 and that reduced number. So this is really 195 degrees. Okay, so now it's a little easier, I hope. So think of what 2 numbers can you break this down into? What 2 angles are that are on the circle? So I want to show you the circle. Think about it. So 195 degrees. So pick two angles that you can break that into. It could be both positive or negative, it doesn't matter. It's something that works. And I'll give you some time to think about it because you're going to have to be able to do that. At 135 and 60. Yeah, I think that does work. Let's see. Got 60 and 135. If you add them together, you get 195. Yeah, cool. That works. Can anyone else give me another one that also works? Yeah, you see that? There's more than one answer. At the end of the day, it's gonna work out. Doesn't matter. So pick whatever you want. Who cares? Okay. But let's go ahead and use that one. So if we use, what did we say? The first one was 135 and 60, right? Since we're actually using radians, we should change it to radians. So that is the same as, so 135 is equal to 3 pi fourths plus 60, which is pi 3 or pi thirds. Okay. I don't have any space now, but so then use the, so this is my alpha and beta. So I can use this for the next A, B, C. Doesn't matter, right? Let me show you. See, as they're all the same angles. You just use your different formulas. That's it. So right here, space. So that'll be the sum formula for sine. Go look it up. Sum formula. Where is it? Okay, so formulas for sum is going to be sine alpha, so sine 3 pi fourths, times cosine beta, so cosine pi thirds, plus cosine 3 pi fourths, times sine pi thirds. So now we just look them up, and we're done. Let me double check everything. Sine alpha, cosine beta, cosine alpha, sine beta. Yeah. So circle says sine of 3 pi fourths, y value, cosine of pi thirds. Excuse me. Cosine of pi thirds is going to be this guy plus cosine 3 pi fourths is negative. Sine of pi thirds square root 3 over 2. All right, multiply it out and we're done. 2 times 3, 2 times 2. 2 times 3 will be negative. 2 times 2, 4. Oh, looks like it's going to be 0. Is that right? I don't think so. That is not right. Let me double check everything. Dang it. Sine of 3 pi fourths is root 2 over 2. Cosine pi thirds. Oh, that's where I messed up. That should be 1/2 here. There's. So it should be root 2 times 1. Okay. Any questions on example 4? All right, let's do something a little harder. Let me show you. So cosine tangent, you just use the appropriate formulas. I'll let you do that on your own. So you already have the hard part, right? The sum that we said on the chat, the alpha and beta. Over here, you need to apply the formula in the other direction, right? So this is sine cosine minus cosine sine, which is going to be the difference for sine. So if you use the difference, that's going to be 2 minus 1.7. So you just apply the formula in the other direction. So we're going to skip number 9 and 10. Okay. So this is basically alpha beta. So turn it into sine of alpha minus beta. That's how they get this. Just using the formula. 2 minus 1.7 is sine 0.3. That's all they want. So you do the same thing here. This is alpha beta. Oops. Beta. Okay. Same thing. This guy, same deal. Apply your tangent formula. This is the one I want to do here. One of these. These are more challenging. Okay. 3 pi over 2 to 2 pi. Do you guys know which quadrant that is? And do you see how that's going to change? That may change a few things. Here they told us quadrant 3. So you need to know the quadrant when you're doing 12 and 13. Okay. Oops, sorry. Yeah, 3 pi over 2 to 2 pi, that is quadrant 4. Yeah, you're right, Arnie. Okay, so that would mean that cosine is positive and sine is negative. So when you're solving for these sine cosines, so basically you're going to build 2 triangles, solve the 2 triangles, and remember what quadrant we're dealing with. So you can put the positive and negatives in the correct spots. So I'll do number 13. And I'll leave 12 to you. Okay. I'm gonna need more space. You guys cool on this page? Okay. Example 5. So they'll find. So basically they're telling us, I'm going to rewrite the question, make it more clear. I try to make it as simple as possible. Find cosine u plus v, right? So that's what they want us to do. And then they tell us, given, right? They gave us this information. Given that sine u is equal to negative 3/5 cosine v is equal to negative 15/17. Okay, so what you're gonna do, and also to give us this hint, right? U and V are in quadrant 3. So that's what they said in the question. I wrote that. Okay. So what we want you to do is basically create two triangles using U, and then the other one using V. Okay. So they said the sine of U is negative 3/5. So they're both in quadrant 3. So you have to know what's positive and negative there, right? Is cosine positive in quadrant 3? Notice, so here's a, don't forget, 1, 2, 3. Here the x and the y are negative, meaning cosine and sine are both negative here, because you can see it, right? Everything here is negative. And that's because this is the positive side, this is the negative side. And we're below the x-axis, so everything is negative down here. So x and y values are all negative. Tangent would be positive though, right? Because you're going to divide negative by negative. But anyway, nobody asked about tangent. So everything is negative there. So that means when we're solving these triangles, both x and the y should be negative. Both the opposite, right? Sine of negative 3/5, opposite over hypotenuse is going to be negative here and there. I don't know what this answer is, but it's going to be negative. Cosine of v, so that'll be adjacent. So this is also negative. Hypotenuse is never negative. So whatever this is going to be negative. So you use this as your clues to build the triangle. Okay. This is a 3, 4, 5 triangle. So I know that's going to be 4. For sure. This is one of the magic triangles. This one's going to be 8. I'm going to skip the Pythagorean step. Is that okay, or do you want to go through it? Do you see, are you comfortable skipping to here? No, just let me know. I can add some more details. So they told us to find cosine u plus v, right? They want this. So we'll look up the sum formula for cosine. That's going to be cosine u cosine v minus sine u sine v. So you see how we kind of had to solve the triangles in order to fill this out, right? So we have, I don't want to smear this, but the sine of u was given to us as -3/5. Cosine u is going to be -15/7, right? I'm sorry. Cosine will be adjacent over hypotenuse, so -4/5. Okay, now sine of v. Sine of v would be, let's see here, sine of, okay. Sorry, give me one moment. Okay. So sine v opposite over hypotenuse. Cosine v -15/17. I'm hoping at this point you're comfortable, but do you see where I found these pieces? Is that clear? We have to build the triangles in order to find these pieces because they're going to have to go here. Cosine u, v, sine u, sine v. So this is from like the last chapter maybe, or beginning of chapter 7. And here we're using the new formula and we're plugging in the pieces that we know with the two triangles. Okay, so you guys are good. So let me know any point in time I can re-explain something. Cosine u. It's right there. Once you have everything, it's just plugging stuff in, right? -15/17 sine u right here. Okay. Cosine u sine v, yeah, sine u times sine v. All right, sorry, just trying to confuse myself there for a second. Inverse functions of fine angles. Let's see here. So you're saying solve for u and v and then plug in those angles in here. That is not it's not wrong, but you may not be given an exact solution. You might get a decimal. So you'll find the answer. But if the question asks for, let's look at the question. Yeah, they asked for exact, so you have no choice. See, the exact value is only going to come from the formula and the triangles, because the triangles give you specific perfect numbers. Solving the angle for something weird like this most likely is not going to be like perfect. So instead of getting this, you're going to get some weird decimal. Maybe if it's a simple question, you can change it into this fraction. but that's only going to work if it's a not really pretty fraction. So, but yeah, I would stick to using the triangles since it's good practice for what you've been doing anyway. But I do like your thinking. It's a good idea. -4 times -15. Okay, 5 would go into there, right? 3, so that's actually just a 12. Minus, minus, minus. Well, that's going to be a minus. 3 times 8. 5 times 17. What is that? That's 85. Yeah. Negative is positive. 5 is better than 15 3 times. 3 times 4 is 12. 17 is by itself. Yeah, okay, cool. Subtract these with your calculator or whatever, doesn't matter. You should get 36 over 85. I'm going to check though. Yeah, we're good. Okay. Any questions on any of these steps? Does it make sense? So as soon as you see, given the information, you start to build your triangles. The signs will be dictated by the quadrant. Once the triangles are formed, you can fill in the blanks for your formula for this. Okay. Well, let's take a small break here. That section felt longer than I thought it was going to be. So we'll stop here for, let's see. Let's come back at 110. We'll start 7 to 5. All right, guys, let's get back to it. 7.5 is, I think, similar to the last section. It's more formulas and more, yeah, quadrant type stuff. So 7.5 product to sum. Sum to product. Number 1. All right, so we have sine alpha times sine beta. So you can change that into a sum of 1/2 times cosine alpha minus beta minus cosine alpha plus beta. Number 2, cosine alpha times cosine beta. That'll be 1/2 times cosine alpha minus beta plus cosine alpha plus beta number 3 sine alpha sine beta. I didn't put parentheses on the first two. It doesn't matter. You can put them if you want. Or it's implied that they're there. Cosine alpha sine beta, that's going to be sine of alpha plus beta minus sine of alpha minus beta. All right, so those are all the product to sums. Now let's do sum to product. So sine alpha plus sine beta equal to 2 sine alpha plus beta over 2 times cosine of alpha minus beta over 2 sine alpha minus sine beta is equal to 2 sine alpha minus beta over 2 times cosine of alpha plus beta over 2. Okay, cosine alpha minus cosine beta. Going to be negative 2 sine of alpha plus beta over 2 times sine of alpha minus beta over 2. Cosine alpha plus cosine beta, that's equal to 2 cosine alpha plus beta over 2 times cosine alpha minus beta over 2. Okay, that's most of them. Still got another set though, sadly. All right. Double angle. So there's 4 of these. So the first one, the sine of 2 theta. So you can change that into 2 sine theta cosine theta. This is pretty handy. I use that pretty often. Number 2, cosine 2 theta. This one has 3 different forms, so you can use whatever you want. Cosine 2 theta is equal to cosine squared theta minus sine squared theta. Number 3, cosine 2 theta is equal to 2 cosine squared theta minus 1. Number 4, cosine 2 theta equals 1 minus 2 sine squared theta. All right. Tangent. Forgot the tangent one. Tangent of 2 theta is equal to 2 tan theta over 1 minus tangent squared. All right, so that's all of the double angle. This is the power reducing, the last set, I think. Oh no, it's not. Dang it. Yeah, we'll go to the next page. I'm gonna wait just a moment. We'll be stopping at 2 p.m. today. Just a heads up. All right, turning the page. I'm assuming you guys are good. Okay. Where was I? Power reducing. This one I didn't use until calculus 2. I don't think they're that useful, but I'll show you how to use them anyway. The book said so. 1 minus cosine 2x over 2. So if you have an even power, honestly, if you have any power 2 or even, you can factor and then you apply this formula. So if you don't want to deal with a square, you can change it into this. And there's a tangent, which is just the ratio of these two. Minus. Okay. Almost done. Now the last one, finally. Half angle. One second. Okay, here is the half angle for sine, cosine. That's going to be plus or minus as well. So here, this is when the you're gonna have to keep track of what quadrant your original angle is, but also the half angle, because you see this could be in a different quadrant compared to this one. And we'll talk about that a little bit. That's all of them. Let's get started. All right, so example 1. Problem 6. Solve, well, actually, let's look at the homework because I'm gonna be making assumptions again. So that's 7.5 that's what we're on now. Okay. Okay. So the first one is just basic apply a formula, right? Apply a formula. And then here we get to solving equations actually. So we're going to have to solve a few types of equations. And these are going to have a lot of answers because it's double angles kind of do that to you, which kind of sucks, but I'll show you why. Here you're just applying a formula. It's not a big deal. These is what I was talking about earlier. You have to know what, well, double angle is whatever. The half angle here. See how this quadrant, U is in quadrant 1, right? But U over 2 might be in a different quadrant. Let's look at another one. Right here. I don't think I see one, but we have to keep that in mind because the formulas have built-in pluses or minuses for half angles. So you have to figure out, okay, what quadrant are you in, and then apply the correct sign. Okay. So let's get to this. Okay. We might have to stop halfway. We'll see. All right. So this is just solve the equation. Okay, so they give us sine of 2x minus sine equal to 0. Sine of 2x equals 2 sine x cosine x. So we can use the double angle formula that I wrote down earlier on this guy. So when you're trying to solve stuff, whenever you're trying to solve trig equations, you have to either A, isolate the trig function, which we did last time, or factor. Currently, we can't factor anything, right? Because these are not the same. But once I change it into this, you will have a common factor. So substitute this with this. So once you've done that, they both have sign in common. So once you can factor, you can set this stuff to 0. Right, because whenever you have something factored equal to 0, you can set each piece to 0. That's something we've done forever at this point. And if you forgot, well, there it is. Okay. Solve for x, right? Move the 1 over, divide by 2, you're going to end up with cosine equals 1/2. So let's do this the easy way. These are easy angles, right? Let's look at 0. Where is sine 0? And which y value is 0? So we got one right there and one right here. Missed that 0. Well, let's do this so I can do that again. I failed handwriting and arts and crafts, by the way, so keep that in mind. 0 and pi right there. Okay, so I go back. Cosine is equal to 1/2. Okay. Where is cosine 1/2? In other words, where is the x 1/2? There's a 1. There's 1. So write those down. The answer will be comma pi over 3, comma 5 pi over 3. So when you have simple values that are known values, you can just look at the circle and not worry about it. But if you get the ones that are not on the circle, like let's say this was sine equal to 1.2, then you're gonna have to do inverse of both sides and use those ideas from last time. Okay. That's problem 6. Any questions on what we did here? You see how we use a double angle to help us? And then this becomes just like the previous section. I think it was 7.3. Yeah. This is the only new thing. After that, it turns into 7.3. From Monday. Okay. Alrighty. Stupid problem. Look at the homework one more time. So that was number 6. Number 7 is very similar. So I'll leave that to you. Number 7. Number 8 is similar, but you're gonna have to use the tangent one. Okay. Let's do 9. That one's not telling us to solve for anything. That one's different. Problem 9. Okay, so I'm not gonna write them. Use double angle to rewrite this. Okay, so we know that 2 sine cosine is equal to sine of 2x, right? That's the formula I gave you earlier. We have a 3, so it's not the same. So we got to force it to turn into this. Okay, so we just got to do some algebra. We just ignore the 3, just leave it to the side. And remember that I can always multiply by 2 over 2 or anything over anything other than 0 on purpose. So now I see I have what I needed, right? It's 2 sine cosine. So at this point, you know what? I'm just going to move that 2 on the bottom over here. I don't need that piece. Now I have 2 sine cosine, which is what I want to use. So this becomes sine of 2x. So I can apply the formula here. Does that make sense? That's all I wanted you to do. Basically force the formula. Okay, any questions on that one? Okay. Example 3. Okay, so usually given conditions. All right. Find sine of 2, use x. This is problem 11. Okay. So they give us this information here. Negative sine u is equal to negative 3/5. And they tell us it is within 3 pi over 2 to u to 2 pi. So which quadrant is that? Yeah, it's going to be 4. So we always got to keep track of that. Okay. They don't outright tell us. So they want to know sine of 2u. So we got cosine. I mean, we got sine, we need cosine. So let's go ahead and draw it over here. So here's u. Quadrant 4, x is positive. Sine is negative, the y value. This is a 3, 4, 5 triangle, so you're going to get a 4 there. Now, when you're solving for it, you need to decide, do I put a minus or a plus on this 4? That all depends on quadrant. So once I have that, write down the cosine. That'll be 4, positive 4/5. Okay. Okay. So sine of 2u. That will be 2 sine u cosine u. So just plug it in. That'll be 2 times negative 3/5 times 4/5. Cosine 2u is equal to, we look up that formula. I don't have the cosine memorized. Double angle I was gonna use one of these 3 here. Doesn't matter which. I'm gonna use the top just because whatever. Cosine squared minus sine squared. We're gonna use those that one right there. So plug in cosine squared minus sine squared. So that'll be 16/25 minus 9/25. 16 minus 9. I didn't even finish this one, did I? 3 times 4 is 12. Times 2 is 24. It'd be negative 24 over 25. There we go. I'll let you do tangent. So that's what they want you to do here. Okay, so you use the given information to build your triangle. you use your formulas to fill in these answers. And that's it. Okay. All right. Any questions on number 3? We'll do 3 more examples, and if there's time, and then we'll call it a day. Example 4. This is problem 13 from the homework. Use power reducing formulas to rewrite the expression. Cosine to the 4th, 2x. That's what they give us, right? So you want to reduce it by using the power reducing for cosine. So remember that cosine squared x is equal to 1 plus cosine 2x over 2. So whatever's in here gets doubled, and then you lose the square. So basically, you have to rewrite this as a square square. Which becomes a, okay, 4x. So see how it goes from 2 to 4. Squared. Okay, so then you gotta FOIL the top, and you gotta square the top and the bottom. So the top would become this when you square it. Okay, so they want us to keep reducing it until there's no more squares. So we're gonna apply it again to this guy. So what I'm gonna do is, that 4 in the bottom is kind of annoying. So I'm gonna move it over here in front. So now I have 1 plus 2 cosine 4x. Then I'm gonna apply the formula on this guy right there again. So that would be 1 plus cosine 8x over 2. See how it doubles one more time? So at that point, we've used the power reducing. We used it once here, and then again. Does that make sense? So at this point, we're done. We just got a bunch of weird fractions. That's about it. So multiply the 1/4 back in. Okay. Yeah, that's right. Okay. Okay. So this needs an LCD. Multiply the top and bottom by 2, and we can combine everything. So 2 times 1, 2 times that, that'll be 2 plus 2 cosine 8x over 4. So now they're all fours. Oh, shoot, actually, this is supposed to be an 8. 1/4 distributed would make this into an 8, which means this needs to be man. Okay. Oh well. That means that these need to be 8s. Let's go back a step instead of adding unnecessary steps. So change them all to 8s. So multiply, I distribute the 1/4 to each term, getting me to here. This needs to be 8s in order to combine it with this guy. So 2/2 would give me 2 8s plus 2/2 would give me 4 cosine 4x over 8. And there we go. I skipped some of the fraction steps. If you want to see it, let me know. If I lost you there, let me know. Once they're all 8s, just put them all together. Two plus 1 is 3, plus 4, plus cosine 8x. There we go. That's as pretty as it's going to get. So let's start from the top, right? So we add a 4th power. I broke it into squared because 2 times 2 is 4. I applied the power reducing that's up here one time, which doubled the 2x to 4x. I squared the top and squared the bottom. You got me to here. Then I noticed, well, I still have a square from the expansion here. Apply the power reducing on this guy. So I applied it there and factored the 1/4. Okay, then multiply in the 1/4, which got me to here. Get everything into 8s using the LCD. Add all the fractions here. And then combine like terms. And that's it. Any steps that don't make sense? All right, well, let me know. Example 4, okay. All right, let's go ahead and keep going. I think we can finish. You guys cool on this page, right? Let me know if you need me to turn back. All right, this is problem 15 from your homework. Use half angle formula. So this is kind of the opposite of what we were doing. You know how we were breaking up a sum. So here we're going to break up at the half angle. This is the idea. Excuse me. Yeah, there's no pi-8 on your unit circle, and they want to determine the exact values. Right, so this becomes half of something that is on the circle. Half of 4 is 8, right? So what we can do is use this formula as your alpha right here. Okay, I think I use alpha in the formulas. I forget, but you see how this works, right? Half of 8 is 4. I'm sorry, half of 4 is 8. So I'm cutting it in half again. Is that weird? Do you prefer degrees? This would be the same as 22.5 degrees. That's the same as sine of 45 divided by 2. So we're going to use the 45 solution for our question. But I'm going to stick to the radians. So plus or minus square root, the formula says you do 1 minus cosine of that angle over 2. There we go. So cosine pi over 4, we know in the circle that's going to be, although before you go any further, you need to choose is a plus or a minus. And that's determined by the location of the half angle. Okay. So cosine, so pi over 4 is in quadrant 1. If you cut that in half, it's 22.5, right? Still quadrant 1. So that means I will choose the plus. So that's why I no longer write plus or minus. I am choosing positive. So 1 minus cosine pi over 4, that would be square root 2 over 2, all over 2. Okay. So positive, I'm going to write you a note here, because pi over 8 is in quadrant 1. Okay. So subtract this, that'll be 2 over 2 minus square root 2 over 2. It's doing fraction stuff, nothing fancy. That'll be 2 minus root 2 over 4. Which will then become square root 2 minus root 2 over 2. So I skipped some of the fraction steps there, but this will be your answer. So this is the exact solution, not the decimal solution, right? Because if I use the calculator on sine pi over 8, I would get a decimal. I will not get this. And unless you have a really fancy calculator, you're not going to get this. But either way, you need to show your steps, right? Okay. I would just do part A. So the last example, you guys have any questions on example 5? The algebra or the quadrant stuff? Okay. This one's super easy. We'll end the day with an easy one. Use product to sum for sine of 5 theta times sine of 3 theta. All right, so you just need to use the correct formula. So we have a sine and a sine. This is my alpha beta. This will become 1/2 times cosine of 5 theta minus 3 theta minus cosine of 5 theta plus 3 theta. So this is coming from the formula on the first page of notes, right? You have a sine and a sine, you use this one. This is the alpha, beta, alpha, beta. And that's it. That'll be 1/2. 5 minus 3. It's cosine of 2 minus 5 plus 3. Cosine of 8. Any questions on 5 or 6? There's nothing else to do there. So those are all the main topics in this homework. There's a few other ones that are, I mean, there's nothing different. There'll just be some that are a little harder or about the same. And if you have any questions, make sure you bring them next time. We'll stop here. You guys have any questions about anything? All right, guys, if you have no questions, you're welcome to head out today. Let me take a roll real quick before you leave. There we go. Yeah, you can head out if you like. And I'll see you tomorrow for the review of this exam. And then if you have questions on homework, we can do that too.